The robotic leg that we are proposing differs in a few different ways from, let's say, traditional robotic legs. So one of the most distinctive ones is in traditional legs, you take a motor with a drivetrain, I say a gearbox, basically, a motor and a gearbox. And by motor, I mean something that has magnets and something that has wire and that sort of spins. You usually put this into the joint of the leg. So you have one link and another link, and you have it in the joint. But for our leg, we use muscles, and those muscles attach external to the joints, so that the joint itself is just a joint, similar to what we have in our bodies. We have also joints in all of our along our skeleton, and these joints do not contain a motor. So we do a very similar thing by having our artificial muscles attach with artificial tendon towards the outside around the joints. The main advantage of the system is that we have inherently a compliant system. So if I take an impact, if I take a hit, or if I hit the ground, or if I touch on something, the forces are traveling through the muscles, and the muscles act also as a cushioning, as a compliant element. So that's similar to when we think about our animal locomotion or human locomotion. We use our muscles for dampening. We use our muscles to take on the hits. So when you walk, you, for example, step on the front of your foot, and then you might tighten your lower muscles on your lower leg in order to, for example, take the impact as you're going down. And so with the ability for having muscles that can contract and therefore also change their stiffness and their sort of behavior, you can start making more natural motions. In the future, we can think about building robots in a different way. So I'm thinking here about building robots using muscles instead of motors. That means we can start thinking of robots that are inherently in the way that they're designed and the way that they behave, they're more suitable to be in a human-centric environment. So if you want a robot to help you in the household or to walk around in the factory and do a task, you do not have a metal machine anymore with these motors and metal links, but you could use these plastic, softer materials for muscles, and you could use carbon fiber skeletons to build lightweight robots that are not massive, heavy machines, but they're lightweight, more bio-inspired and more gentle creatures that could interact with you. And so we basically want to show with this work that we're thinking we should have a paradigm shift of how you're building robots.